All right, this is Mr. Wyrick. I'm not going to be there today, so I wanted to make sure and have a video for you. We're going to go over this 12-12 review, but it's a set of Delta math problems. So I'm just going to go down through the skills. I've written out a problem on paper so you can see me work through it and kind of explain what's going on with that. So we'll start with this very first one, transversal problems with equations. So I had this one written down. I actually worked it wrong. Go figure. Sometimes you got to make mistakes in life. But we have the corresponding angles. We could have also alternate interior, alternate exterior angles. We could have vertical angles. Remember, those are all those different ways that angles can be congruent if we have those. You might check back in your notes if you're not sure about one of those relationships. Anyway, these are corresponding angles, so they're going to be congruent. If it was none of these relationships, remember, they would be supplementary. They would add up to 180. So I've got 9x minus 23 is equal to 7x plus 9. I'm going to begin by subtracting the 7x. I guess I should draw my line for those faithful in second period who need me to draw that line. 9x minus 7x, sorry, is 2x. So I've got 2x minus 23 is equal to 9. I add 23 to both sides. I get 2x is equal to 32. I divide by 2. And this is where I made my mistake on the last one. This should have been 16. When I put 16 in here, 7 times 16 is 70 plus 42, which would be 116 plus 9. And 116 plus 9 is going to give me 125 for that angle. 9 times 16 is going to be 90 plus 54, which is 144 minus 23. I think I did that multiplication wrong. Yeah. 90 and 54. Yeah, that would be 144. 144 minus 23. I don't know. I know this is right. Okay. I know we should have x is equal to 16. If you're asking me what the angle is, hopefully this is a multiple choice test and Mr. Wyrick's not too tired to get this one right. On the next one down, slopes of parallel and perpendicular lines. This one was a multiple choice kind of thing, as most of the delta maths kind of are when there's around this. It says find the slope of a line that was parallel to this one that was given. You are going to have to dip back into those Algebra 1 skills and solve for y here. So I subtract x. That's going to be 2y is equal to a negative x minus 14. I'm going to divide everything by 2. So that should give me y is equal to a negative 1/2 x. And then it would be minus 7. The minus 7 is not really important here. The only thing that's important is your slope. If they're looking for one that's parallel, it has to have that same slope of a negative 1/2. If we're looking for the perpendicular for that, I put my slope down, I flip it, and then I change that sign. So it would be a positive 2/1 or just a positive 2. Okay? So that should get us in the right spot for that one. The next one is called parallel equations. So this time they gave me the one and it was in slope-intercept form already. And then they were giving me a lot of different standard form. AX plus BY is equal to C. If you want to know what that would look like if I were to take this one, and make it into a standard, what I would do, and this is kind of me, I would multiply everything by 7. So I'd end up with 7y is equal to a negative 4x, because that gets rid of that fraction, and then minus 28. So then I would add the 4x back to the other side. So I'd have 4x plus 7y is equal to a negative 28. So that would give me that standard form again. I wouldn't necessarily have to do that. And I just realized I was looking at the wrong one. I was looking at the parallel and perpendicular equations, but same kind of thing, okay? This would give me one that was parallel. If I change the sign on either one of these, if I have a negative 4x plus 7y is equal to that negative 28. Or if I had a 4x minus the 7y is equal to a negative 28, that would give me my perpendicular slope. On this one up here, with the parallel equations, same kind of thing. If this is 6x minus 5y, I would do like what I did up here. I would subtract the 6x, subtract the 6x. That's a negative 5y is equal to a negative 6x plus 10. Divide by negative 5, divide by negative 5, divide by negative 5. I end up with y is equal to a negative divided by a negative is a positive. So that would be 6/5. And then a positive divided by a negative is a negative. So that would be minus 2. So if I'm looking for a parallel one, it needs to have a slope of 6/5. You could probably find a pretty quick shortcut for just getting the slope over there. Subtract that 6, divide by the negative 5. That would be your slope if you needed a quicker way to find a parallel. Okay, we'll take a look at the next one. All of those are kind of the same. Slopes of parallel and perpendicular lines, parallel and perpendicular equations. If you just remember, if they're going to be parallel lines, that's the symbol for parallel, then they have the same slope. If they're going to be perpendicular lines, that's our symbol for perpendicular, they have to have opposite, reciprocal, or you put your slope down, flip it, and reverse it like we did right here. Okay, the next section is bisector, midpoint, or vertex on the diagram. These questions are a little wild. They have some different things on here about like what's going on here with this little segment. I went ahead and drew what I had going on here because I just wanted to talk about everything that this does. First off, I can see that these two are marked congruent. So that means L is a midpoint. So if that's one of my options, I need to select that option. That's a definite correct answer. The other thing I can say for certain is that JL as a segment is a bisector. Okay. Now, if I was looking at anything else here, I can't prove it. I don't have the capacity there to take care of that. So I would mark these two, but nothing else. They may look like, this is totally an isosceles triangle or something like that. But again, if it's not marked, it's not something that we can prove. If I'm looking at this one that's popping up right now, I can see that MN is a segment bisector. It's not marked as perpendicular, so it can't be a perpendicular bisector. There's no angle here, and I'm definitely not cutting that in half, so MN is not an angle bisector. The angle bisector would be cutting an angle in half. N is the vertex of a pair of congruent angles. No, this angle is not the same as this angle, so it doesn't work that way. Even on my drawing with point L here, I can't say that for sure. They're not marked. N is the vertex of a right angle. That's not marked as a right angle. N is the midpoint of a segment in the diagram. Yes, it is. This part and this part are congruent, so N is definitely a midpoint. So that would be something that I could say pretty definitively about what's going on with this. Okay, I don't know if there's any on here. Yeah, there's one that would be O is the vertex of like a right angle. Okay, S is a midpoint, TS is a bisector, ST is a bisector, T is a midpoint kind of thing. So just be on the lookout for exactly what the diagram is telling you. The next one, the Triangle Inequality Theorem. I wrote down this one. This one was looking for which one is not a triangle. Remember, basically all you have to do is check the two smallest ones and see what's going on here. So 8 and 14 would make 21. So that's bigger. So this one's a triangle. 4 plus 6 is 10. That's bigger than 7. So that one's a triangle. 4 plus 14 is 18. That's bigger than 17. That's totally a triangle. 6 plus 8 is 14. That's equal to 14, not bigger than 14. So this one's the one that would make a triangle. Remember, those two sides of that triangle have to be longer than the third one so that they can touch and form a triangle. If it was the exact same distance, this would be a straight line and not a triangle. On the flip side, the next section here, this is one of the ones that I think is probably the easiest, the solving for the interior angles of a triangle. We just have to remember they add up to 180. So 180 minus 58 is going to be 122. And then I subtract 47 from that. That's 5, 7. So this last angle here should be 75. You can do that a number of different ways, but I just find that subtracting the other two angles all at once or adding them together and then subtracting them, that's going to be the quickest. The next one is the Triangle Congruence criteria. They give you a couple of triangles. They say, hey, can you prove these congruent or not? Remember, we have angle, side, angle. We have side, angle, side. We have side, side, side. We have angle, angle, side. That's the kind of complex, weird one. We have hypotenuse, leg, and you can put a star by this one. I don't know if they even have that on there. It's mostly focused around these right here. Okay. I'm forgetting one. Angle, side, angle, side, 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 angle, angle, side. No, I think we've got it. All angles would just be similar. It wouldn't be congruent. This one here, angle, angle, side, angle, angle, side. That's that complicated one. So you not only have to say like yes or no, they're congruent. Don't forget that horrible arrangement of letters that would be angle, side, side. So this one, all they've got is angle, side, side. I think they put it in the other order. Yeah, side, side, angle. These cannot be proven congruent. Okay, side, side, angle, or angle, side, side, however you want to say it. Not a valid answer in geometry. See, everybody knows it. Even Delta Math knows it. No donkeys in geometry. The next one, solve for the side or the perimeter when you have similar triangles. Again, we just have to find the ratio, but you have to do it by matching up those angles, okay, in just the way that we want. For me, the way that I would want this one is the 75 and the 60. If I put the small triangle over the large triangle, I can see that these are both divisible by 5. So if I divide by 5, I get 12, and then I get 15. And I know that those are both divisible by 3, so I'm going to get 4 and 5. Okay, so 4 over 5, that's my ratio. Between the 55 and the 50 is what I'm looking for next. And I have 88 on my big triangle, and I have X on my small triangle. Okay, so I would cross multiply these. 8 times 4 is 32, and 32 again. So this is 352 is equal to 5x. I divide by 5. And I'm going to get 70.4, I believe. Okay. And then if it's asking me for the perimeter, I would put my 70.4 in here, add the 56, add the 60 all together. Just make sure you read on these. I'm only asking you to do a couple of them. These are probably one of the most time-consuming ones on there. The last one is one that we had some experience with on Friday's assignment, word problems. Similar triangles. You get the ones that are like this with the lake, or you get the ones that have like the river that you got to cross, or you get the ones with the tree or the mirror and the tree. I happened to get a tree, one of these. What a great triangle. So on this one, really, again, it's little to big, and it's trying to figure out what's going on. So there's some work to be done here on this. It gives me the distance of the person to the tree, but not the person to this vertex point over here. And it gives me the distance from the tree to the vertex point. So the first thing I have to do is take 21.55, and I have to subtract 16.6, because this is going to give me my small triangle. 5 minus nothing is 5. That'd be 15 minus 6 is 9. This would be 20 minus 16 is 4. So this is going to be 4.95 here. So my ratio is going to be 4.95, 95 for my small triangle and 21.55 for my big triangle. Remember, it's not about big measurement, small measurement. It's about finding this small triangle and putting the ratio properly over the big triangle. We're going to find the height of this tree right here. So we're going to compare the height of the person at 1.85 meters. That's actually a pretty tall person. to my X height of my tree. I'm going to cross multiply these, and my cross multiply on this is just going to be 1.85 times 21.55. Then I'm going to divide by that 4.95 because I know that that's a shortcut. I'm going to go ahead and do that in Desmos or on the Delta Math calculator if you really want to do that. So 1.85 times 21.55, and then I'm going to divide that by 4.95. I can do that all in one step, and I get a whole bunch of weird numbers out here, but 8.05 would be my answer on this one. So 8.05 meters. I mean, it's a 25-foot tree. That's kind of a big deal there, or somewhere around a 25-foot tree. Okay, hopefully this gets you through your assignment pretty well. We will still have the test on Tuesday. I anticipate being back there in class to give you that test. So use this video to your best advantage, and good luck.